Okay, so in lesson 4, I believe, we looked at how to use substitution and elimination to solve a system of equations that has 3 different variables. So we have x, y, and z. Today, we're going to look at another method to solving systems with 3 variables, and this one is going to involve matrices. So as you can see up here, this method is called Cramer's rule. And what Cramer's rule allows us to do, instead of using substitution or elimination or graphing it, which is also an option, Cramer's rule tells us that the x variable is equal to the determinant of x divided by the determinant of the 3 by 3 matrix that we make from this. Then same thing for y. Y is equal to the determinant of y divided by the determinant, and z is equal to the determinant of z divided by the determinant. We will talk about what the determinant of x, y, and z are right now. This formula is just going to be important to notice before we begin. So if we start by turning this system of equations into a 3 by 3 matrix, we get this matrix. You'll also notice that we converted the system of equations into a general formula. So we have the coefficients of x represented as a1, a2, a3, the coefficients of y as b1, b2, b3, and the coefficients of z, c1, c2, and c3. And then we just turned the answer into d1, d2, and d3. We'll get to that in a second. So let's first start off by calculating the determinant of this 3 by 3 matrix, which we just did in the last lesson, so we'll go through it pretty quickly. So like we did in the last lesson, we're going to start by emphasizing this first row. We'll start with a 2. So we get rid of the first column in the first row. That leaves us with 2 times the determinant of this matrix. And then remember, we have to flip the signs as well. So we're going to do minus 1 times second column, first row. And then we have plus a -3. So we'll do minus 3 times 3, 6, 1, and -1. Now, if we continue to calculate this, we have 2 times 6 times 6 is 36. -1 times -4 is +4, so -4. -3 times 6 is 18, plus 4. And -3 times -1 is -3, minus 6. 36 minus 4 is 32. 2 times 32 is 64. Minus 22. -3 minus 6 is -9 times -3 is +27. So if we add this all up, we get the determinant is equal to 69. And we will use this information later, so I'm going to put this all over here. All right, so if you'll remember the formula, it was the determinant of x or the determinant of y divided by the determinant. So now we need to figure out the determinants of the 3 different variables. In order to do that, what we're going to do is let's use dx. Instead of putting the a1, a2, and a3 in the first column, we're going to switch it out for d1, d2, and d3. And then these 2 other columns are going to be the same. Now, the reason why we're switching out the first column is because the first column are the coefficients for the x variable. Since we're doing the determinant of x, we're going to switch out that first column. When we do the determinant of y, we're going to switch out the second column. And when we do the determinant of z, we're going to switch out the third column. But for now, this is what we're going to work with. So if we get rid of the letters and we plug in the numbers, we're going to remember put the d's first. So we have 6, 20, 14. And then the second and the third column are going to stay the same as these ones. And now we're just going to calculate the determinant of this 3x3 matrix, just like we did for this one. So we have 6 times. That was not right. And then minus. And since I know you guys already know how to calculate the determinant of the 3x3, we're going to go through these pretty quickly. Fourteen times 4 is 56. All right, 6 times 32 is 192 minus 176. Negative 20 minus 180 or minus 84 is negative 104 times negative 3 gives us 312. And then this tells us that the determinant of x is equal to positive 328. So we'll write that one up here as well. Okay. So now we figured out the determinant of x, we're going to switch to the determinant of y. And like I said before, in order to do that, we're going to switch out the second column for these d values right here. And that means the first and the third columns are going to stay the same as well. And now we're going to calculate the determinant of this. I don't remember what that one was. Two times 176, 352. 6 times 22, 132. And 3 times 22 is 66. And there we have the determinant of y is 154. Okay, and now we will finally do the determinant of z. So just like we did for the determinant of x and the determinant of y, we're going to switch out the third column now, and we're going to replace it with these 3 numbers right here. And that also means that the first 2 columns are now going to stay the same as the original matrix. Okay. Six times 14. 84 plus 20 is 104 times 2 is 208. Minus 22. The -3 minus 6 is -9 times positive 6 is -54. And that gives us 132 is the determinant of Z. Okay, so now if we go back to our original equation, which I wrote up here, we have x is equal to the determinant of x divided by the determinant. Same thing for y, and same thing for z. So now we have all of our four numbers that we need, and we're just going to plug them into the equation. So x is equal to the determinant of x is 328 divided by the determinant, which is 69. Y is equal to the determinant of y, which is 154 over 69, and z is equal to 132 over 69. And then if we want to put these in decimal form, we have x is equal to 4.75, y is equal to 2.23, and z is equal to 1.91. Okay, so we have our three different variables. Now we want to make sure, we went through all this work, so we want to make sure that our three variables are actually right. So what we can do, just like we did before when we're solving systems, we can take our three values and we can plug them back into one of our equations. So I'm going to erase this so that we can do that. And let's do the bottom one here, just because that way we're multiplying by the least amount of numbers. So we have 4.75 minus 2.23 plus 6 times 1.91. And if that equals 14, then we know we are correct. And that does gives us 13.98, but because we rounded to 2 decimal points for all of these numbers, we're gonna just count that as rounding error. And we got 14. If we plugged those three numbers into these two equations as well, it would also give us 6 and 20, just like we needed. So now you might be asking yourself, why am I doing it this way? Because this way took probably way longer than it took to do any of the other methods for solving a system with three variables. And although this probably is not the most efficient way to solve three variable systems, if we wanted to add a fourth variable or 5 or however many variables we need, it's going to be the same process, except let's say we added a fourth variable and that was W. So then we would have a 4x4 matrix. We would do the same process, and to find W, it would be the determinant of W over the determinant. So it's not the fastest way for a 3x3 matrix, but if you have more than 3 variables, this is definitely going to be the fastest way to solve the system. All right.